Hello, welcome to my CS6963 final project presentation. My name is Troy Hildebrand. This is a summer 2013 semester of CS6963 installed by Professor Joel Fernandez. So the goal of my final project is to create a bulk extractor plugin that extracts images. While this may seem like it's something that's been done a bunch of times already, um, in addition to the educational aspect of learning how to do the plugin, I wanted to add something to it. It's not just that it extracts images, but it's configurable at runtime. Now, the configuration that is at runtime is the definition of what is a file, what is the format of a file. I've gone through and I've looked at, in particular in this case, JPEG, GIF, both 87A and 89A, PNGs. Those three file formats are the primary targets currently. But if other formats should be made aware to me that have a defined start and defined end, then as far as signatures, then they could be added to this extractor and they could be extracted by this extractor without any changes to the code, just to the configuration file. So that's the unique part of this one, is that I'm making it a dynamic definition of what it's looking for. Okay, so I wanted to give you an overview of the development system. I'm running Fedora 19. I downloaded from fedoraproject.org, and it's running inside a VMware player virtual machine. You might want to install VMware tools in order to copy files back and forth between your host machine and your local machine or your guest machine, because it does get a bit tedious to move files through thumb drives or other mechanisms. If you have a shared drive, then you can just mount it and do it. All my files I need are already on the machine, so I'm going to just go from here. So in order to get the bulk extractor to build, there are a few dependencies that Fedora needs. I'm not going to go through the steps, but I will describe them here to you. There are some good bits of documentation here and there, but some of them are on GitHub, and some of them there's a bulk extractor programmer's manual as well. But the long and short of it is you got to get the development tools installed and the OS up to date, and you also have to install Flex. I've found a few other things. So you need to use sudo to do the yum installs. That gets you super user access. So you do sudo yum update, you do sudo yum group install development tools, and sudo yum install Flex. That puts most of the development pieces on the machine that you will need in order to develop the bulk extractor plugin. You need to get the bulk extractor source. You can download that from GitHub, and you just go to github/simpsong/bulk extractor, and then it will give you an option to download a zip. That's what I did, because since I'm not planning to well, that's nice. Since I'm not planning to do anything with this long term as far as contributing it back to the community, because I don't know that it's the quality that the community would want. I didn't feel like I needed to actually go through the live GitHub repository. So anyway, I downloaded the zip, extracted it to my home drive, my source folder. There were a few other commands that I needed to run actually before I ran the configure and bootstrap, because there were some additional dependencies not installed. So sudo yum install autoconfig, sudo yum install gcc-g++, and sudo yum install openssl devel. So installing these three items would then allow me to, and sorry I've got them in the wrong order, would allow me to run the bootstrap shell file and the configure. all of which was necessary in order to make a Makefile. So once we had the Makefile, we could cd into the bulk extractor folder and do a make, and then we can do a sudo make install, which puts it in like user bin bulk extractor, something like that. And in order to install the plugins, or I'm sorry, to build the plugins, you need to repeat the bootstrap and configuration steps, which are we cd into plugins, we do sh bootstrap.sh, and an sh configure. And once you're done with this, you've got a Makefile that will then allow you to make the plugins as well. So from there, then you do make plugins, and then scan demo and scan flex plugins are automatically built by using that command. Okay, so once you have your development system building bulk extractor and plugins, you need to tell the plugins about your plugin. And mine is called Scan Troy. I know it's not very creative, but that's what I did. So I go in the Makefile, which is in the plugins folder, and it's only there after you've successfully run configure. So if you don't have a Makefile, then you're not yet running. You've not yet run bootstrap and configure. But so I went into the Makefile and saw everywhere that it was doing anything with scan demo, and I added scan Troy. So if it's a CPP file, I added a scantroy.cpp in the line. So scandemo.d, I added scantroy.d. Scandemo.o, added scantroy. So I continued this throughout the entire file. Everywhere I found scan demo, I added a similar line with scan Troy. Okay, and once I did that, I went in and I copied the scandemo.cpp to scan Troy, and I'm about yeah. So if you're building this a plugin for bulk extractor, you know that the entry point is going to be scan underscore your name. So my entry point, of course, is scan underscore Troy. It takes a const class scanner params and SP and recursion control block RCB. I'm not doing any recursion, so my RCB is never used. I've broken it up a little bit here, so I check the phase each time, each time it runs in to scan Troy. This is the only entry point, so it's like a state machine. It says here's my phase, and if it's a startup phase, I run a startup routine. If it's a scanner phase, I run a scanner routine. If it's a shutdown phase, I run a shutdown routine. So in the startup routine, I do just a little bit of housekeeping. I declare the name of the scanner, my name of course, and the title is of course configurable image extractor. We do some housekeeping with the feature recorders, and then we do the read config. This is a special thing for mine. I wanted my plugin to be configurable, so I've got a config file. And I'll give you more information about that, but just suffice it to say that this is where the image formats, the definitions of what the image looks like, are located. I have to do that in the scanner phase because I only want to do it once. I load it into a static variable that is then accessed in a thread safe way, but it's only done once. I don't need to do it every time I scan. That would be redundant. So to give you more information about the configuration, so let me describe a little bit about what my goal is here. My goal is to have a configurable image extractor, and when I started looking at images, I noticed that there's several formats that have fairly predictable format. They all have a start signature, or not all of them. The ones I was interested in have a start signature and then an end signature. Some of them have a thumb signature and then a thumb end signature. For example, JPEG has um, a start image or start signature, and then inside that you can have a thumbnail, which is another image that has its own start signature and an end signature. So a lot of times what you'll see is a start image, and then an end image and an end image, and in that you've got a thumbnail in the middle of a bigger image. So I've made it so that we can extract thumbnails and main images. So the config file, I wanted to be able to capture all this information. I got a lot of this information from Wikipedia. GaryKessler.net has a file sigs section. It's a lot of good information. But the JPEG starts out, of course, FFD8FF is the signature, classic signature, and then it ends with the FFD9. And if you're gonna have a thumbnail embedded that's a JPEG, um, you'd have a FFD8FFDB. That's this right here, and then the thumbnail would end with FFD9. Similarly with GIF, there would be this is actually the signature right here, GIF87A or GIF89A, and these are the hex codes for those letters. And then the ending signature is 00 and 3B. Now notice that GIF does not have anything for a thumbnail. It doesn't support thumbnail. My scanner can support that if it doesn't see a thumbnail. I'm sorry, if the format that I've defined doesn't have a thumbnail format, then it will not do anything with the thumbnail. So I've gone through and I've looked up the codes for several different types. We've got the PNG, which is 8950 da da da, and then it ends with the 4945 4E44. So then I needed my image format defines those things and has some initialization and all that. But I needed a way to read it in and out. I've got some utility functions here for printing messages. That's not very important. I've got some utility functions for looking up in the array. I create an array that's called formats. Okay, that when I'm loading the format, or when I'm reading the config file, I add these to this array. I add the items that are found in the config file to the array. So we've got several different functions here. We've got the get format, which just looks up by name, says, okay, if I have a JPG name, is that already listed in my formats array? If it is, then it returns a format number. If it's not, it says -1. There's no format called JPG or whatever. And then add format basically reserves a slot in the array for your format and then tells you what number you were given. Build hex takes a signature, an array of bytes, which is this here, which when it's in memory it doesn't look like 47, 49, 46, 38, etc. And you can't really present it to the user very well. So the build hex takes and does a sprintf with %02x, which gives us the hex code instead of a binary representation. And it dumps, and then you can take that value and dump it to the screen or whatever. So then describe formats just does exactly that. It goes through the array, which is a global array, and skips any blank ones. But if it's not blank, it will actually output to your screen or optionally to a recorder. The name, the extension, the start signature, and the end signature. And if there's a thumbnail, it'll show you the thumb signature and thumb end signature. So I go through the actually I go down here. I read the configuration. I open up my config file, which is set to be scan_troy.config. I open that file, and for all the lines I've got in it, I parse that line. And really, these lines here can be contained in any order because I have the relative information here. So you put these in any order, it would still create the a valid format in memory. So parse each line and break it up into the pieces and add those pieces to the global array. It's not really interesting work right here. This isn't the meat of the work. But it does give me some flexibility in that I'm reading the configuration. I'm reading the pieces of memory that I'm going to be comparing to from the disk at runtime. It's not hard coded. I'm not bound to the codes that I've preordained as formats. So that's what I do here in the startup thing. And when startup is done, I end up with a global image. That's actually a vector, not an array, but a vector that contains a bunch of image formats. So let's see. So once I'm done reading the configuration file, I'm going to come back. The bulk extractor we'll call scan_troy with a scanner sp.phase of phase scan. And this one's the one that needs to be, anything within here needs to be thread safe. And it will call this multiple times on multiple threads, and with providing different buffers, different chunks of the input file. And so what I do here is we got some housekeeping. I had some trouble with I tried to create the output folder, the where I carved my folders or files into. Tried to create that in the startup phase, but for some reason I couldn't get the feature recorder to provide me the output dir correctly. So I just did it here. I guard it with a global variable, so I only do it once. Anyway, so then we get down into the meat here. This is where we actually go through the sp.sbuf. We go through every byte. We start at 0. We go to page size. We increment by 1. So basically, what we're looking is does the current byte offset, does the current position of the SP scanner parameters buffer, does the current position of the buffer match any start format? And if it does, then we make a note of it, and we've found a thumb start. Oh, so there's I've got two variables that tell me if I'm inside a thumbnail or an image. And if I'm already in an image, then I'm looking for a thumbnail. If I'm not already in an image, then I'm looking for an image. It's kind of a logic trick here to make it so you don't have to do everything every time. So anyway, so basically when you start the first byte, you're not going to be in an image, so you're going to come down here and you say, oh, I'm not in an image, so let me look to see if my current position in my buffer matches any start. Then I have a current image. And if this returns a non-1 value, that means I've found an image start. Make an alert to that point, and then continue. Don't need to do any more processing because I've gotten to the end of what I can do with a start. So I go back up to here. Then the next time I come in and say, oh, I'm in an image, is my next byte a thumbnail, or is it start another image? If it does, then let's make note of it and continue. So now we can find you can see how we can look for the start of a image or look for the start of a thumbnail. Then we continue on down, and if we're in an image, then we start looking for a format end, and we pass the current image format because we don't want to find a TIFF file end, or I'm sorry, a GIF file end while we're already inside a JPEG. So we look at the current, we take the buffer and start in its current position, and see if it has any current image format end characters. If it does, then we make note of it and set a flag, and then follow through. We do the exact same thing with a thumbnail, except we're looking at the current thumb format. We come down here, and if during this pass we completed an image, we record it with the write buff off of the feature recorder, and then we extract the image. We set the image completed to false, and we continue on the whole array, or doing the for loop through all the bytes. We do the same thing for thumb. We write the buffer, we extract the image, and set it to completed. So I've just talked about how the loop goes through, and on every byte it checks for the first byte, checks to see if there's an image starting at that byte, or if it checks to see if a thumbnail is starting at that byte. I got those two backwards, but and then it continues on and checks to see if there's endings. So we're going to go ahead and look at what those two methods do. Does buff match any format start? Okay, so that takes the scanner parameters and compares. Let's see. So it looks through all the formats and says, does this buffer that we're looking at match this array? So it looks at the SP buff inside here and starts at this point, and for all these bytes, if there's 4 bytes, it compares the start signature to the buffer. So let's go ahead and look at that. Okay, so this is a utility function that basically takes an index into a scanner params SP buff, or SBuff, I guess, and says if it doesn't match, return false. And then if we get all the way through, it returns true. So it's really a simple, quick way to compare an array, which is what we're looking for, to the array, which is the data that comes in. That's contained inside here, and then the format number start signature is the array we're trying to compare against. So that tells us if it looks, if the current format matches. It can look for a thumbnail. It looks for the start signature, and also looks for the thumb start signature. And if it finds either of those, it returns the format number that it found. Okay. So this is what we do here for the thumbnails. It's what we do for the images. Very similar thing is done here with format end. It says, does this match the array? So basically, all the plugin does is it compares arrays. It says, okay, does this array, I'm looking for this array, is it here? Oh, if it is here, then I found a match, and does that in a controlled way, and tries to keep track of it. So where are we at? So let's go ahead and see what happens. I've got some examples to show you. What I've got here is my test batch file, so I can easily rerun bulk extractor multiple times. First thing I do is I clear out my temp folder, clear out any carved files, remove that folder because it will be recreated by the plugin. Clear my screen, and then I run bulk extractor. I use the dash capital E and then my name to tell it to only execute um, my plugin. That way I don't have to wait for any other plugins to finish in order to see the results. So I tell it that the plugins folder is /plugins. Tell it that the output folder is going to be /temp/be out. And my input file currently is in my home directory files folder and file called input file. Now this, if you remember the mini challenge 6 from the Sci4 challenges, the input file is that it's a TCP flow of a Wireshark capture, a PCAP file capturing the loading of the mini challenge 6 file. Anyway, so I've captured that. I've put the file here. I don't have any good images to try to carve, so I just assembled this file, or I've got several files that I've assembled, and I'll describe how I did that in a bit. So I've got this file, and I've got a command prompt. So of course, I've got my make file, or my make batch file. It says remove scantroy.so, clear the screen, and then make scantroy.so. So just to show that it works, I'm going to do /m. It does all this run, and ls-l scan troy.so, and it's got the current date, which is really late in the morning. So I'm going to do /t. That's nice. What? So we're going to go ahead and run this. We'll run the t, so /t, and it's a lot of output, right? Okay, so I'm going to go ahead and capture that into a text file so we can actually look at the output so you can see what's going on here. Oops. Okay. Open t.text and t.error.text. Standard in, or standard out, and standard error. So standard out is pretty simple. It's mostly just, in fact, it's all just standard bulk extractor stuff. 10 megabytes per second, not horrible. I've had it better and I've had it worse. So my output is all contained within t.error.text. Now, one of the things I do is describe formats. What that does is it goes through the memory array or vector of formats and lists what it thinks it understands. So these are the files, if you remember. Okay, so we defined the different files or different file formats: FFD8, FF, FFD9, etc. So you can see here. Okay, so we have a format called JPEG. Its file extension is JPG. Start signature is FFD8FF. End signature FFD9, etc., etc. So it describes to us what it understands about files. I'll talk about fake format in a minute. So as it goes through, it outputs a byte offset into the SBUF, and it says, "Hey, I found an image start." And a few bytes later, it found an image end. And then it says that, "Oh, I carved this file." Okay, I named it. I put it into /temp.be out, and I put it into a folder. This temp.be out is from bulk extractor, which is actually from the command line to bulk extractor, the -o /temp/be out. But we get that from the feature or from the scanner parameters. I add a Troy carved, and I add a scanner name dash start byte dash end byte, and then add the extension onto the end. And you can see it continues and it finds another GIF, another GIF. Oh, and then here it finds the image start at 168.577, and then a few bytes later it finds another JPEG start, which is puzzling, right? But not really, because then it finds a JPEG end and it says, well, this is a thumbnail. It actually found a FFD8 FFDB inside an FFD8 FF. Okay, so then it found the ending FFD9, and so when it found the ending for that, it carved that file, Troy dash start byte end byte dash thumb.jpg, because it is a thumbnail. It's an inset image. And it found another JPEG end and carved that file. And it continues on and on. I think there's, it tells us here down at the bottom, it found 9 JPEGs and 7 of them had thumbnails. It found 6 GIF 89As. None of those had thumbnails, of course, because it doesn't support thumbnails. And it found 1 PNG. So let's go ahead and see what we can find in that folder. Be out. Okay, of course, here's the folder. If I look at those files, well, there are that's our files. So if we look at this one, it's if we look at it with Shotwell, okay, it tells us, I don't know how to use Shotwell to tell us what the resolution is. Anyway, so but then if we look at the other file, this the same, looks like the same thing from here, but it's a thumbnail. It's the same picture, but much smaller, which makes sense because it's actually a thumbnail embedded inside this file. Okay, so one of the cool things about bulk extractor, so obviously we can carve files out, and that's really cool. But it also gives us the feature files. So let's go ahead and if we look at, let's do VE viewer. Open up the report. Okay, it shows that the actual image file is the input file. All right, and here's our files. So it shows us right here. This was a PCAP file. The image file started out as a PCAP file, which is a capture of a bunch of TCP flows from, or TCP sessions from a web session to the mini challenge 6 file. Anyway, so I just assembled those in no particular order, the TCP flow conversations, and then threw them into this file. And as we look at each of these, we can see the different files. This part right here is actually it's hard to see because it just represents it as dot dot dot. A lot of times these really small GIFs are space holders. They're probably 1 by 1 images or 1 by 10 or really small images. Okay, well, there's actually a byte that's different. But so then if we look at the FFD8 FFDB, that's a thumbnail. For some reason my image is not highlighting this because it doesn't match exactly based on this pattern, the \XFF. But if we look closely, we would find it. So 169.173. It's gonna be in this. It's in this row here. We can't see it because of the font. Anyway, so there's a PNG, the GIF, and we got all those files. So then we also got the alerts.txt here. It gives you a little bit of the ability to give a little more context. I found it a little bit awkward using the feature recorders because it was hard to control what goes where, and it's just really fairly confusing. Documentation hints at what to do, but it doesn't. There's not a lot of good examples. So anyway, so that's what we have here. I'm going to go ahead and run a couple of other examples. This should show that it did pull up quite a bit of data. So let me set that up, and I'll be right back. So I did some surfing, maybe 10 minutes or so. A whole bunch of different stuff going on. Don't remember even what it was right off the top of my head. I saved that in random TCP. So when I create these files, what I do is I start up Wireshark and capture all the traffic from my machine and export and then start surfing. I do whatever I need to surf, web browsing, and then export a PCAP from that. Then I run Simpson Garfinkel's tool for TCP flow, TCP flow 32.exe on Windows, that goes through and looks and finds all the TCP conversations it can. And so, and then I take all of those files and just concatenate them into a single file. And that's what ends up into, say, NBC TCP flow or random TCP. Okay, so they're basically a bunch of surfing that has been gathered, and the capture has been all accumulated in order, so the files are, so you don't have, so it's not broken down into 1500 byte chunks, but they're actually contiguous conversations. So random TCP, it has some random surfing in it, so I'm going to go ahead and do that, and I go ahead and do /t. And so you notice it took a few seconds there. So I'm going to go ahead and do BE viewer. Okay. And then notice that the file is much longer now. I don't have a count here, but there are a lot of files. This one's actually looks like it's going to be, oh, it's 15 megs. Yeah, 15 megs long. So it's pretty good size. Okay, so as I mentioned, I've got some issues with the alerts. The feature file, it's not able to extract data, but that's okay. The point is I'm still extracting the data. I'm just not recording it super well. So okay, so that's exciting. Let me go here, and then we'll go to back to the file viewer. Go to the output, the carve folder, and as you can see here, we have hundreds of files. This is showing everything that I surfed for that 10 minutes or so. Okay, looks like I'm not sure if this is on NBC or what it was, but obviously this would be a useful tool, even in its current form, to see what images have been surfed. So I mentioned earlier that this wouldn't necessarily be limited to images or photographic images, but that it could be used for anything that had a clearly defined start and end. Um, so to prove that point, I made up a fake image format. It's not even an image format, but it's a fake file format, and so I call it fake format. The definition of this format is it starts with f underscore a underscore k e, right, and then it ends in fake with it backwards. Then it's got a thumbnail or embedded part that's called thumb, separated with underscores, and then backwards thumb ends the thumb signature. Okay, so this document is it's a special format, obviously, and it contains some secret information. All right, and here's a secret that's in the thumbnail, the executive summary. All right, so I've got my batch file set up so I can extract test fake, which is this file here. All right, so I'm gonna go ahead and do that. So /t, and it's a very small file, so it's very quick. First, I'll go to my output, my Troy carved. There's two files here. One is the fake format, one is the thumbnail fake format. So if I just go ahead and open up both of these, okay, the extracted fake format from byte 0 to byte 410, 110 is the entire file. Well, that's pretty cool. And then my open didn't do both of them, so let's go there. And then the thumbnail, of course, just brought out the thumb. So it proves that this can be, and that's actually defined down here, fake format, okay, has an extension of fake format, has a title, a name of capital fake format, has a start FAKE, EKAF is ending, and same thing with thumb and thumb end. All right, so I was surprised how few image formats could be found that had a start and an end that were so clearly defined as JPEG, GIF, PNG, and let's see, and fake format, right? So a lot of the other formats require some fairly heavy analytical processing to figure out where in the file you are and the different chunks of it. I wanted something that would be configurable and dynamic, that could be extended. So there's some options that could be done to make this even more extendable, like to look at in the header section to look for a length, and then just seek to the end of the file by byte or by offset rather than looking for an end. But that was outside the scope of this of my goals here. Thank you for taking the time to watch this presentation. Again, this is Troy Hildebrand. This is CS6963, summer 2013. I appreciate your time and wish you luck in creating your own bulk extractor plugins.